So guys, again, welcome back to unit number 4. So in second video of unit number 4, we discussed about role of CMM. In this video, we will be discussing about types of CMM. So actually, CMM, as I said, particularly main axis, if you say XYZ, then other which your role will add on, that will comes under degrees of freedom, but mainly XYZ. Under Cartesian coordinate system, it will be functioning based on the physical configuration. CMMs basically divided in many numbers, but mostly people will be categorizing under 5 categories like listed here, like a bridge type, cantilever type, horizontal arm type, gantry type, and column type. So basically, these 4 are very important in that. Along with that, portable CMMs also there, optical CMM also there. Configuration wise, bridge, cantilever, horizontal arm, and gantry are main. If you know about horizontal arm, maybe column type also almost similar. Only thing how the probe is positioned in horizontal arm, maybe probe positioned in horizontal axis, but in column it is placed vertically. Similar like others, but the structure wise almost like same. So let's see one by one. Each and every type structured type of configuration of CMM possess some benefits. Let's see one by one. First one, bridge type CMM. Bridge CMMs mainly featuring probing system that moves along with the 3 axis XYZ. Each axis are orthogonal to each other. We should remember that since Cartesian it is orthogonal to each other. X, Y is orthogonal, Y, Z is orthogonal, X, Z also orthogonal to each other in the Cartesian coordinate system. Each axis, for example here, X, Y, Z orthogonal to each other. Each axis will be having sensor. Why that sensor? In the sense it's a kind of monitoring device and also will be acting as a feedback device also. So each axis has a sensor. That sensors monitors the probing positions. Means z-axis will be having a probe. For example, if that y, this column is here, probe will be here with related to y, and in this column is placed here with respect to this axis. So each and every position will have a xyz coordinates, right? So each axis has a sensor that monitors the probe position in millimeters or micrometers as it moves along the object and detects the points on the object surface. For example, if you are keeping an object over here, like if you consider like one engine block you are keeping, engine block will be having some height and length, width, all will be there, and different features will be there. For example, there is a bore, piston bore, and move down. If you are moving down, the depth will be there. So like that, multiple data you can able to get. Coordinates X, Y, Z, all will be converted as a detected as a point, discrete points, and stored, and represent that will represent our what to say coordinates of the object. Then using these points or those points, we can prepare a point cloud. That point cloud, like a collection of points, with that point cloud, we can able to represent or illustrate the surface of which we are measuring. Okay. Then we can able to process for the further operations. Either we can able to measure it, or we can able to compare or gauging with the existing one. So this is what. So basically, it will be having three axes, and the axis like X, Y, Z, and there is a base, and there is a column, and in this column you will be having a vertical column. In the vertical column you will be keeping the Z probing system, which will be moving up and down, and in this vertical column will be traveling along with this horizontal column, that is acting as a Y, positive direction, negative direction. Then also it will be moving, the X axis moving in this one. So in under this bridge type CMM, you will be having another subclasses. One is movable table, another one is a movable bridge. Either we can say movable table or fixed table, or movable bridge or fixed bridge. So in this, from this diagram, we can able to understand the difference between these two. So here it doesn't matter about z y-axis and z-axis. It will be performing its same principle. But only thing is how the x-axis, whether this setup, the vertical column type, is moving along with this table, or that vertical column will be fixed, table will be moving. So you can able to find the difference. The table will be moving in x-axis, or here the vertical column will be moving along with the x-axis. So this is what. So under this, you will be having like a one side, any one side only having the mechanism for driving or driven. Other side will be playing or acting as a slave side, which will follow the commands given by the another side. Okay, and most of the bridge type CMM machine will come with the driven mechanism will come with air bearings, which will allow friction free movement and minimize the mechanical interaction. If you are adding lots of mechanical interaction like a pinion, rack and pinion mechanisms, or gear mechanism or something, lots of moving components, friction may happen, it will affect us. So they try to avoid all the things, and they are using air bearing so that friction free movement will go, and so that we can able to achieve high accurate and precious measurement also. So the same thing applied. Only one side of the bridge is driven, the other side is the slave side, that is allowed to float freely on the bed. 95% of the bridge machines run on air bearings to allow friction-free movement and minimize mechanical interaction. In fixed bridge type, a vertical moving arm, that is z-axis, is mounted on a carriage. The carriage, that is x-axis, moves horizontally on bridge structure fixed to the base, and a table y-axis moves horizontally on the base. So that is what explained as explained in this one. If you consider a bridge type CMM, fixed table in the sense, table will be fixed, this vertical column will be moving in x-axis, and in this y-axis, the vertical column like which mounts the probe will be traveling up and down, and also traveling in the y-axis. So what is accuracy? So accuracy of fixed bridge configuration is higher, because fixed bridge configuration in the sense, table will be moving instead of bridge moving. So fixed bridge in the sense, table will be moving. That horizontal column with y-axis and vertical column with z-axis probe will be fixed. Only depth, for depth movement, the column, the vertical axis column like z-axis column will move up and down. Other y-axis beam may be traveled, but x-axis movement will not be there. Only table will be moving. The table which kept the component will be moving forward or backward. Then the moving bridge, as the servo drives are located at the center of gravity. If you want movement in fixed bridge moving, then you need servo motors. So which lead some errors in your measurement, could lead to measurement compared with fixed bridge. So comparatively, fixed bridge is better than your moving bridge, because in moving bridge again you are adding servo drives, to move the bridge, so it could lead to some error. So while people are using prefer a fixed bridge in the sense, they'll be avoiding the error caused by the bridge movement. Okay, and range. What is the size range for the bridge type is 300 by 300 by 300 millimeter in XYZ to like ranges starting from 300 to 2000 by 5000 by 1500 millimeter. X-axis 2000, 300 to 2000, Y-axis 300 to 5000, and Z-axis depth 300 to 1500 millimeter. So we can call this one like bridge type CMM as a work horse of CMM. So other name we can call that one as a workhorse CMM. So this is the bridge type CMM. It also has benefits and disadvantages, pros and cons. So one of the most accurate types of CMM, we can call it as a bridge type CMM, ideal to measure machined parts with the high tolerance. If we are having high tolerance value, we can able to use bridge type CMM. If the component which being measured having high tolerance, we can measure using bridge type CMM. Perfect for small to medium sized component. You can't use heavy components because the range it is given. So accordingly we can and enabled for multi-sensor measurements such as probing and scanning. So probing will be used for measuring, scanning also possible. Okay, scanning also possible using this digital CMM. What are the disadvantages? Basically expensive, have a fixed measured volume because of the structure and dimensions are fixed. So fixed measurement volume, you lack of portability. You need to bring that part to the system or use machinery to move them around. Okay, you have to bring the component which is needs to be measured or evaluated or tested with the CMM. You have to bring it. Since four legs will be there or you are keeping down, vibration will be affecting the quality. So better to keep it under metrological lab setup where vibration free environment can be possible and record rigid setups for each inspected part. You need to have a rigid setup, complex to operate and need skilled workers to program the device. Yes, in CMM lab also you might have seen like a small programming is needed to handle that front end software, so you need program. Then application in the sense for machined and pressed parts we can go plastic molding components we can casting or forged product we can check and can be used for scanning and also for probing. So digitizing, scanning or reverse engineering also possible. Touch trigger or non-contact inspection. Like a non-contact inspection in the sense for scanning, we can keep some instead of probe, we can keep some other sensors over that y-axis. Touch instead of touch, we can go with the optical system or light ways to scan. So non-contact inspection also possible in digital CMM. The next one is the cantilever type CMM. Otherwise, it is called as a shaft floor CMM. This is quite different from the earlier bridge type one. So the structure or shape is looks like that. One end is fixed, another end is hanging out. So simply it is called as a cantilever type. And its range it depends on x-axis. How much the column is like x-axis, then you can move along this. This is the measuring range, and here you can move around this y column and vertical depth you can. But here one beauty is you can keep the part or you can take bring the part to the measuring table in three direction. One here, two, three direction. Three directions possible. But in terms of here, it is difficult. Only one and two way, either here or here. But in terms of here, you can have a three ways. So cantilever CMM differs from bridge type CMM as the measuring head is only attached to the one side of the rigid base. So this is the rigid base, here it is attached. Cantilever CMM provide open access to inspection technicians on all three sides of the each operation. So it's for the technicians is beneficial because they will be having three side access. So they can able to keep it easily the component being needs to be measured. Generally used for measuring relatively small parts, they provide open access to operator on three sides. The x-axis measuring beam is attached on the side of the rigid structure housing the y-axis. So x-axis measuring beam is measuring beam. This beam attached on the rigid structure which houses the y-axis. This limits the size of the x beam, which limits the x beam because of inherent rigidity, making the machine suitable only for smaller components. You can't test a heavy or bigger size component in this cantilever type CMM, only small component. A shop floor CMM, the cantilever machine excels because it lends itself well to automatic loading and unloading. So you can automatically load and unload so that inspection can be easily. So you will be having three directions. Again, the advantages: high accuracy, highly accurate. Only for small components we can. Three sites possible to access and easier to manually or automatically load and unloading the components being tested. Then disadvantages like can be expensive. Similar, you need a fixed measurement volume only. You will be having only fixed measurement volume. Portability, lack of portability. You need to bring the part to the system, even though three sites are there. Loading, unloading is the automatic loading, unloading there. You need to bring that component. It is also affected due to vibration. So you have to keep this one under the special environment like metrology lab. Simple metrology lab, why we are telling metrology lab? And this is like an environment friendly or environmentally controlled one, controlled environment, including temperature, the humidity, even in your in CMM lab, you might have seen it is closed room and pollution free. Because if you have a lots of dust or pollution, since it's all moving components, air bearings are there. Some dust or particles go inside means it will affect the movement or it will disrupt the movement of axis movement. So it is difficult to achieve the accuracy or precious measurement. Not possible. So you need a controlled environment. That's why they are always recommending better. And also vibration will be affected. So you have to have a proper foundation for setting up the CMM machine. Require rigid setup for each inspected part, complex to operate and needs skilled workers to program the device. That's it. Then another way we can explain the advantages: large measuring range, maximum accessibility. We can because all ends are open. Particularly this end is open in the sense you can cover entire. According to y-axis range, you can cover all. Disadvantages: since it's a hanging cantilever type, bending is possible, so it may affect quality or accuracy of measurement for in long run. It is, as I said, it is for small sized components only we can able to measure. So for checking sheet metal, cast iron and the steel parts in automotive industry or aircraft construction and shipbuilding industry application only we can able to use. Then next one is the gantry type CMM. It is almost similar like a bridge type CMM. However, bigger in size, much bigger comparing with bridge type. This gantry type is much bigger, mostly used in automobile industries. Okay, they are usually much larger. They designed to eliminate the need of lifting of the component. So you need not to lift the component or part being tested and break. But in bridge type, you have to load and unload. You need a special attachment or the setup to bring the component to the CMM machine, bridge type CMM. But in terms of in gantry type, you no need of having any special equipments to lift the component. You can bring the component directly. Like since it's like as I said, automobile component, you can bring the vehicle to that table. So it's mainly for regularly used for very heavy or large component. So hence it needs to be mounted on a solid foundation directly on the floor, not on some legs or something. Directly on the floor you have to keep. If you consider about the smaller gantry type, it may be having four or upright columns will be there, supporting large y-axis beams. The ranges is 1.5 to 2 meters in height. Okay, that column, vertical height column for gantry type is 1.5 to 2 meters long. The x-axis carriage runs on the two supported beams of the y-axis. Okay, there is a vertical columns, pillars kind of thing. Then there is a y-axis. Then z-axis will be mounted. Then x-axis this x-axis 1, 2, 3, y-axis and z-axis will be there. Okay, so ranges they get given. Large gantry in the sense instead of four rigid upright columns, like in small gantry type, you will be having four upright columns. But in terms of large gantry type machine, you need more than four, either six, eight, or even more number of vertical columns is needed depending on the total length of the y-axis. Okay, that x-axis, z-axis, which is located on the x-axis carriage, has a depth of 1.2 to 2 meters, not millimeters, the meters in general. But if required, the depth can be extended up to 4 meters also. So measuring range, it is given for gantry is 1 by 2 by 1 meter in XYZ direction to 4 by 10 by 3 meter XYZ. Up to 4 also possible for this one. So range is meters. Up to 10 meters we can have in Y axis. Okay. So this is the structures like a vertical column, one, two. So for example, this is the small type of gantry. If you consider large size of gantry type system, instead of one, two, you may be having three, four, five, six, seven, eight, like vertical columns, maybe more. There you will be keeping your y-axis and z-axis movement also there. This column. So this is highly accurate, large measurement volume compared with other type fixed column type or bridge type. You might have seen that it is fixed measurement volume, but here large measurement volume possible, which facilitates what measuring large and heavy parts possible. It's also easier to load or unload the components than the bridge type. It's easy comparatively. Then cons like a disadvantage, you can say that expensive, have a fixed measurement volume, or for example, if I am telling you I have a fixed measurement volume, this depends on how many legs you are keeping. Flexibility is more here because you can increase the legs vertical column instead of 2, 4, 6, 8. But if you are fixing, it is fixed volume only. Portability is new. You need to bring the part, even though easier to load or unload the components than bridge, you have to bring the part to the system. You can't take this towards the component, you have to bring it. Lots of floor space, yes. If you are increasing the vertical columns, you need lots of place or area to cover. It's also vibration will be affected the measurement, so you need a controlled environment. You require rigid setup for each inspected part and complex to operate and needs skilled operator. Example I said like if you consider this one, large size components possible, geometrical changes caused by non-uniform temperature distribution owing to their large. Particularly since it's a heavy, you need metrological lab setup also, even though you are thinking it's a big environment in the sense, some have some possibilities of environmental changes may happen due to the temperature ununiformity. So that is the one of the drawback could be. And heavy machines construction for car body or mold making sectors of the automobile industry, measuring wind tunnel models we can able to. Simple example, I added a pictures here. You can see this one. Okay, the columns, vertical columns, y-axis, the z depth. So you can increase here. You can see 1, 2, 3, 1, 2, 3 is there, or you can have a 4 or 5 or 6 also. But that meteorological lab setup, free from vibration and all needed. Special setup is needed for this kind of CMM machine. Then another one is the horizontal arm. This is totally different from what to say previous type CMM. In that the probe is kept horizontally. Horizontal arm CMM, as their name implies, have horizontally mounted probes. So here is the probe. You can able to see the probe here. Have a horizontally mounted probes as opposite to vertical mounted probes like other CMM. In other CMM, probes are in y z-axis direction, but in this horizontal arm CMM, probes is kept under horizontal direction. See, even though the column is moving up and down, the probe is moving y-axis. So measurement probe movement in y-axis. Other probe movement in z-axis, but here y-axis is the probe movement. So you should remember that, and they are designed to measure long and thin objects. Okay, long and thin objects, if you want to measure, particularly kind of sheet metal, metals kind of component with sheet metal in the sense thin. Okay, you know what is sheet metal? Up to 6 millimeter plates or sheet metal with 2 mm gauges. Sheet metal can be explained, represented in terms of gauges, like 24, 32 gauge kind of sizes you can able to measure. So horizontal arm CMMs are often used to inspect geometries that are difficult to reach. If you can't able to reach by the other CMM type, you can use this type of CMM. There are in that horizontal arm CMM, you will be having two types again. One is plate mounted, another one runway mounted. So what is plate mounted? What is runway mounted? We'll see. So these advantages and disadvantages will come later after seeing the two types. So one is plate mounted horizontal arm CMM. Another one is side mounted. So in plate mounted horizontal arm CMM, plate mounted horizontal mount CMM, column x-axis is mounted on a large surface plate. This is the surface plate. You can say this is the surface plate, x-axis. Where is x-axis in this one? This is the x-axis. This x-axis, this is the large surface plate. Okay, this x-axis are mounted on the large surface plate. Large surface plate usually made up of steel. So made up of steel. These machines have two types of configuration. One is top mounted and side mounted. This is top mounted. Another one is side mounted. So from the diagram itself, we can able to see what is the difference between top mounted and side mounted. So top mounted in the sense this movement that particularly that horizontal arm CMM components kept above this plate, like a surface plate made up of steel. So it takes some of the portions of the surface plate. So range of measuring range will be limited in terms of top mounted one. So top mounted CMS are quite inexpensive in general and less accurate than side mounted system. Also in the case of top mounted configuration, most of the surface is taken up by guideways for the vertical column. So the surface plate cannot be utilized for putting the component on it for inspection. Because this one kept here, so you can't able to keep big component or measure comparatively. However, in terms of side mounted system, this is the side mounted system, allows the whole surface. This whole surface can be used for measurement. Why? In the sense, this setup will be kept under the this sideways. Sideways will be there in both sides, either here or another side also. So according to your need, you can keep component sideways. You can keep this setup measuring here, measuring setup here. So in this axis it can move, or keep it another side and move. And also closely you can able to see there is a probe, horizontal probe only. So that's why this is horizontal arm type. The probe is horizontal only. Okay. The measuring size of the horizontal arm machines varies from 2 by 2 by 1 to 4 by 10 by 3 range. Okay, from 2 to 4 in terms of x-axis, and in terms of y-axis 2 to 10, and in terms of z-axis 1 to 3 meter we can able to. And as I said, it has a two types, top mounted and side mounted. Comparatively, side mounted will be providing better measuring accuracy and also wide range possible, because it is the measuring heads are kept in the sideways, inside guideways, not on above the surface plate. Then final one in terms of commonly used CMM structures, column type. Maybe you can able to see this is like a slotting machine, simple slotting machine, maybe slotting machine. The tool will be moving up and down in the z-axis, and you can move this table also y-axis, x-axis. Then again, this is useful only for small component compared to all other CMM. It's only for very small components being tested, maybe in in-house labs, and then they will be using this kind of CMM machine. So what are all the type we have seen as of now? Like a bridge type, then cantilever type, then gantry type, then final one horizontal arm type. Under horizontal arm type, what are the benefits for horizontal arm type? If you say it can measure long measurement volume and the long and thin parts we can able to, and sheet metal components we can able to measure. Good for parts requiring low tolerances. Okay, for parts requiring low tolerance can be measured. It doesn't require a significant foundation comparing with the gantry type or bridge type or other type like maybe what to say gantry type or cantilever type. Yeah, cantilever type. It doesn't require you much foundation. It is quick and easy to install because that either type, top mounted or side mounted, you need a surface plate. Then inside mounted means if you have gateways, you can mount it, or top mounted means you can put it on the top. But other types you need special setups comparing with this horizontal type, and it requires less ceiling height than other types of CMM, but it again depends on the range. So range of this horizontal arm is up to 3 meters, so you need that much space only, but comparatively cost effective, but accuracy wise less than other CMM. You need to have a fixed similar like other fixed volume only we can, and the portability near low vibration will be affected. You need a rigid setup for inspecting component needs to be placed rigidly, and you need special skilled operators. What else? Plate mounted, runway mounted. Okay, that's it. Then column, then portable. I think this also you might have witnessed in our lab. I don't know whether it is you witnessed or not. It is like a ferro arm. You might have seen ferro arm. It's also similar like a robot, which is available in our robotics lab. Okay, so portable measuring arm CMMs are coordinate measuring machine that can take measurement of parts right on shop floors, allowing for quick results and real-time analysis. This is flexible, very flexible. You no need of like a big setups compare with the gantry type or bridge type, and all this is a simple one. You can use this for measuring the dimensions, coordinates in real time using teach content, and you can get back the results, analyze it immediately. And so here the operator or the inspector needs to bring the component to the lab and place it over there. Then he'll be using some teach content or some joysticks to move the component. The move the joints and links available in the CMM, so that the probes will be contacting the object to be tested and giving the data. So basically, it is the portable one. You can bring the CMM to the part. You can move if you have a movable base. You can extendable measurement volume. You can increase the length of measurement also. Enabled for multi-sensor measurement such as probing and scanning, possible scanning also possible. Comparing with other type, little expensive. You know, not necessary any programming compared to other. Joystick alone sufficient, but Probo Studio kind of software also there, so you can use it in that. Comparatively less accurate than other CMM, sensitive to environmental vibration, definitely it will affected by the environmental vibration, requires a rigid setup for mounting if once you started measuring. The final type under CMM is optical CMM. It is happening one not very much popular other than like other type of CMM. So optical CMMs are portable, non-contact device. These CMMs uses arm-free system. You don't doesn't need any arms like this. system with optical triangulation method to scan and record 3D measurement objects. So you need a special processing softwares to process the data from the optical system, and which is ultra fast and guarantee metrological grade accuracy. We can able to get it. Also useful for industry 4.0 manufacturing. This optical CMM comparatively providing low accuracy than low accuracy for wide range of application. If you want to use for wide range of application, it provide you low level of accuracy than the conventional or traditional CMM machine. So mostly in production they won't be preferred. Maybe still it's in the beginning stage, so people needs to work out more on optical CMM and provide and implement this optical CMM in wide range of applications, but slow or slightly lower level of accuracy only, and also slow. So people won't be preferring now. They will be preferring the traditional type or conventional CMM only. Then other is the features of CMM. We'll see about this in the coming videos. Okay. As of now, you guys witnessed about types of CMM. Start with bridge type, gantry type, cantilever type, horizontal arm type, and column type, and portable CMM and optical CMM. Okay. I'm closing this video. We'll see you in the next video. Thank you.